Hello everybody, this is Sylvain Rochon, the Peaceful Revolutionary, for another installment this week of some really cool science and tech. In this case, it's something I've been looking at for a long while, as you know. I've been talking about it: artificial intelligence, self-driven cars, some specific topics. But today I'd like to talk about artificial intelligence in general. In particular, some kind of new things that I haven't talked about. Things that are kind of upcoming in 2017 that is a little bit more niche than the self-driving cars, things that you've seen in the news about artificial intelligence. Because I mean, honestly, it's pretty much everywhere. You have it on your smartphone with Siri, kinda. Like I mentioned, self-driven cars and things like that. Just the advancements of computing and operating systems and things like that. This is all known stuff, but what's actually moving, what's really interesting is that we know of these domains that are that have artificial intelligence of some degree, even robotics, for example, like car manufacturing. It's not really AI. The self-driving cars, that is artificial intelligence. They're even trying to do a version 2, which is more to the operating system for the self-driving cars, where it's you give them motivation, a little bit of a consciousness of sorts, so that it can the car can react to different situations like a human would, to situations that are unpredictable, that you can't really program in. Right, so we know all about that, but there are some efforts by pretty big companies like IBM and other smaller firms even to bring AI to different parts of our lives, to our social life, to research, to work, to farming, and different things like that. And I'd like to talk about that. Like in 2017 and going forward, not only 2017, there's going to be more and more efforts to include AI in different aspects of our work and our lives, generally because there's stuff that we can't do. There's knowledge that we don't know that computer would, because a computer AI has access to all the information of the internet. And we have to read about it to know about it, or spend a number of years, right, to learn different things, and then we become an expert, and we know because we fill our own computer and our brain with different data. Most people would prefer, I assume, including myself, to not have to actually gorge our brain with information all the time just to be able to achieve different tasks. What we prefer to do, which typically people do, is that if they don't know something, they jump on the internet, they jump on our smartphones, and they check. So we do what an AI would do, but an AI can do it way more efficiently. Because if they don't know something, generally they're an empty shell in some ways. They always check their database, the data bank, and the data bank can be like a Google search of information on the internet, for instance, right? So they have direct link, and because they're not with two legs like us moving around doing different things where we may not have access to our device and we have to figure out how to do the keywords. They're not like that. They're already programmed to do that, and they're already connected to the internet in absolutely every minute of every day, so they can get multiple answers way quicker than we would. So what's going on actually in some of the examples is that, well, instead of us doing that work of gathering information that is very, very available, you can ask an AI using our voice to do the work for us. And search for that, figure that information out for us, right? And without even using voice, you can even use pictures. Using smartphones, okay, computer, could you tell me what this is, for example? And the AI figures it out, doing all the search for us, and puts out an answer for us that we can understand. This is what's coming. Actually, in some ways, this is what is right now. I'm going to give you a couple examples just to illustrate the world that is transforming, and the world that we are in a way. There is a team The researchers from the Penn State University and the Swiss Federal Institute of Technology. So, Switzerland and U.S. researchers, created something that is really, really neat. They created a neural network. Essentially, it's an AI connected to a computer network, cluster of computers that contains all sorts of photos of plants that are diseased and healthy plants from all over the world. And so it has a database like a memory core, let's call it that, which is essentially a cluster of computers that are interconnected. And they created a software, like an AI, that is able to look at those images and compare with images that can be taken in the field, like in a farm, for example, by a farmer. And it does the analysis. It looks at different things and figures out, okay, well, this plant is this specific plant. This is corn. This is maize. This is not maize. This is corn. This is potato. This is whatever it is, right? It can identify the plants. And if there's a disease in the picture on the plant, it'll be able to identify the disease on that plant as well. And that's really valuable information. Now, in the Western world, in modern world, farmers have a lot of education, have access to the internet, and so they can identify a lot of that stuff on their own due to experience, right? Long-term experience in the farm from father and son and whatnot. And also somewhat have fairly quick access to experts that can advise them on what kind of pests are causing this, what kind of disease this is, and that kind of deal. It takes a bit of time, but they have access to that. For smaller farms or farms in the developing world, they definitely don't have access to any of that, so they have to figure things out on their own. Now, imagine that you have how many? It's like I was looking this over. There are 5 billion smartphones in all parts of the world right now. That's like like the population is what, 7 billion? You have 5 billion smartphones that are alive and active right now. Okay, that includes in what we call the developing world. In the third world, there's a lot of smartphones, lesser quality, but still they exist. You can install an app that was developed by these researchers, for example, and the farmer, instead of calling an expert, which is unavailable or can't afford, or is too small for it, or he's in the field, it's an emergency. You can just take a picture using the app, and the AI is going to to tell him, well, this is your plant. This is this plant type, and it's this disease. Now they did the experiments with the software to see how accurate it could be, how the AI was accurate, and it was accurate at 99.35%. So over 99% of the time, the AI was able to identify both the plant and the disease, or no disease, whichever picture that was taken in the field. This is amazing. So can you imagine the applications in the knowledge sector? This is for farming, but there's lots of situations where, for example, bird watching, or you're walking in the forest and you're kind of figuring out, you're looking at stuff like an insect or anything. You don't know what it is. Is there a problem with it? Is it male, female? You could just take a picture, and we could probably have like a similar AI to figure out, well, okay, well, this is this bird. It's a male. It's X amount of years old, and give us a lot of information. Things that are only an expert would probably know, right? But we just we have an extended expert AI that is on our phone, and we carry it with us. Very, very practical for lots of different careers and jobs, just for leisure. Just like you're asking yourself, what is this? Or can I eat this? Like you're in the forest and you're hungry and you want to know if certain berries are edible. I'm using that as an example. Take a picture of it, just show it to the AI. Say, oh, this plant is this such and such plant. This is edible and it's eaten here. You can eat, or this is like, don't touch it. This is terrible. That kind of thing. The extension of this kind of software application AI is very, very vast. Very interesting. Make our lives easier, and of course, something I'm excited about. A lot of jobs can be eliminated by that because there's a lot of people whose job is, for example, to prospect for ore. Right? I have a friend of mine that's his job. He goes out into the wild and does some prospecting for companies to see what's going on. Well, he can do it more efficiently, or he can be replaced. You can just have some of the people just walking around probably and chipping away some rocks, taking some pictures, and then just visually it can be analyzed what kind of rocks are in there. I'm assuming, because I'm not an expert in there, but that's potential application that can be really cool. Okay, now let's look at another example of application which is a lot more social. This was an experiment done by IBM's Watson AI, becoming quite famous because Watson has written a cookbook. He's crafted a movie trailer. He's joined a debate team, able to debate on a topic with real debaters, and also has helped in the past in medical education. Of course, the links are down below, and you have the cross links as well within the articles. And more recently, I believe, and this is not in the article, but I believe this is the computer that was also responsible for composing the first ever musical composition, like a completely novel musical composition. Well, completely novel. In that particular case, the music was created, music and lyrics was completely created novel, but it was based on like a number of thousands of different pieces that were already existing. Now, one can call this creativity, or one can call this copying. And I guess the deeper question in that particular example is, what does a human do in order to create an original piece of music? And does it compare to what Watson did? And it would be I would argue that humans do exactly the same thing. We are not inspired by out-of-the-blue concepts. We're inspired by our memories. So you have a bunch of sounds and music and lyrics and things kind of jumbled into our brain, and the creative individual can kind of take pieces of his history and his memory and put it in a new way, and so it's fashioned from bits and pieces from his memory. So did Watson do something similar to that? I would think it's similar. So is it a brand new work that could be qualified as art? I assume so right now. I think so. It's not, because it's not unlike what a human artist would do in creating a piece of music. Anyway, I digress. IBM's Watson's been prolific and been doing a lot of really, really cool things, and his voice recognition and synthesis of voice is actually quite excellent. In the article I have below, there's a video, and you can hear him, Watson, actually behave. Now, this particular example is a little bit different. Because it's more social than just like trying to show off Watson as a creator, as a creative guy, or anything like that. What they did is, this was at Jefferson, I believe. Jefferson? Man, I can't find it. Jefferson Hospital. Thomas Jefferson University Hospital. Okay, in Philadelphia. What they did as far as programming for this particular for Watson is that they connected him with all the information of the hospital. So they gave him access to a database of all the doctors, scheduling, and for the cafeteria, pretty much everything that is associated with the hospital, and also connected it in IoT, so Internet of Things, to the rooms of the patients. And now you have a speaker, and you have also like a microphone kind of set up inside the room that picks up everything that's going on in the patient's rooms. Okay, and the patient or whoever's in the room can verbally ask Watson to do all sorts of stuff inside the room, like changing the temperature, changing the lights, different things like that, changing the channel and TV on and off. Different things that a patient may need to do and perhaps can't do on his own because he's a patient and may not have the mobility and whatnot. But also you have all the information, about food, doctors, scheduling, visiting hours, everything like that is related to the hospital. Now, I mean, it seems pretty mundane for an AI to actually do that, but what's been felt by the nurses and the doctors is that, well, most of their time what they want to do is deal with emergency situations, life-threatening situations. But a lot of but some of their time, which is I think I was reading up to 10% of their time, especially for the nurses, well, both the nurses and the doctors, is spent at responding to very mundane requests by the patient. Things like, when's lunchtime and things like that. Things that are really, really not critical. But they are spending 10% of their time responding to those things. It's already pretty hectic in the hospitals, as you know. And their wait times, and you're dealing with life and death situations. You don't want really the staff that is trying to deal with life and death situations to deal with very, very simple things. So if a patient is there, can just ask Watson in his room to change the lights, change channels, get times, get backgrounds from the doctor that's been treating him, all that stuff, but without bothering the staff. Awesome, right? The doctors and nurses are winners. The patient doesn't need to go out, roll out, or call someone and wait, and just ask the computer essentially to do that. And the AI is very responsive and understands pretty much everything. You can check the video inside the article. Is pretty good. Again, this is like customer care. You can imagine this kind of computer being used in pretty much any kind of client care situation, and inside the homes as well. You can have your own personal assistant, access to all sorts of information, and also connected to everything in your house, and you can just have a dialogue and ask it to do all sorts of things. Hospital is one micro system where it can be used very efficiently, but I can see systems like that. I can see Watson program like that in all sorts of offices and homes and pretty much everywhere, making our lives way easier with just access to information and access to the systems like the infrastructure, so that we just have things faster and better. And it has diagnosis. You can put sensors to it, so it knows what's going on everywhere. So if you want to have the weather, for example, right now you look at your smartphone, an app, it takes us 5 seconds, but you have to locate the smartphone to have access to your computer, whatever. Well, instead of doing that, just ask. Watson is connected to this information constantly, and just verbally ask, your AI friend, Watson, like, what's the temperature out today? What's the predictions for tomorrow? And he's going to let you know or display it, right? This is literally things that are being implemented in real locations in 2016, 2017, and we're going to see a proliferation of AIs such as these pretty much everywhere, right? So this is really, really cool. Now, here's another addendum to the AI proliferation idea, and this is a prediction for 2017. It's not really a prediction. This is happening. And I mentioned the rollout for the cars, the self-driven cars with AI is 2020, because that's more complex. There's infrastructure. There's all sorts of stuff. That's why it's a little bit down the road. But by the time the self-driven cars come out, we'll have AI everywhere. We won't need to tap and do that stuff anymore. We'll just have like pickup recorders everywhere, and AI being able to respond to us from all sorts of locations as long as it's installed as a system, right? Very, very neat. Very, very neat. Now, here's the other bit, is that, computers are still running these things, of course, logically. And we are pretty much at the limit of what we can do as far as efficiency for computers. So there's a lot of work done in quantum computing, organic computing, and things like that. But what I discovered is also in the traditional mechanical computing components, right? Like we still use transistors, smaller and smaller ones. But there's a team. Oh God, see, my memory's bad. There's a team. Okay, maybe you can check out the article where the team is, but I know it's a Korean guy that is leading the team. I just don't remember where the team is. Anyway, this is research. This is not application, but still, I'm adding to the whole AI schema. we are still building these AIs using traditional components, transistors and whatnot. Traditional computers, just the programming is way more enhanced and the computing power has increased. Now, if we can build using the same without completely changing things to going organic or going quantum, if we can change those transistors and making them more reliable, more energy efficient, and smaller, then we're bypassing some problems in miniaturization that we are currently having with mechanical computing. And this team, they figured out a way to use metallic compounds. So traditionally, like we all do, we use gold and silicon for circuit boards nowadays, and some other metals. If we can use the similar materials, it's more easily introducible, if that is a word, into the market as a new way to build computers. So you're replacing your transistors with something else, and they are calling these things. Oh man! See, when I look for something, I can't find it. Mem something. Jeez. I'll figure it out. Anyway, I'll figure it out. Memristors. Okay, so the replacement to transistors, memristors. And they do essentially the same thing. The transistors, what they do is they flip between 1 and 0 to give like on or off, and that creates a machine language, right? These memristors are smaller. They do the same job and require less energy, and they can be smaller. They can be as small as 4 nanometers in width. That's a human hair's width is about 100,000 times bigger than that. This is tiny. To give another frame of reference, the distance between atoms is usually measured in angstroms, which is 1/10 of a nanometer. So really 4 nanometers is a few atoms wide. It's very, very small. And this, the memristors, why they called it that is because it behaves very similar to human neuron synapses. The synapse of a neuron is your own biological transistor. Essentially, it's fired or it's not. So it's a 1 or a 0 in a sense, but it also has a gray area. It's more efficient and it's more accurate in a way. As you can, instead of 1 and 0, you have intermediate states until you kind of go to a kind of a breaking point where it hops to a 1 kind of deal. But it reacts in a more dynamic way. And so these memristors are mechanical, but they act more like a brain's transistor or synapses. So we're getting closer, and human brain is the most efficient computer we know of it, like super efficient. It's really, really great energetically. So if we can do, and this memristors, I have trouble saying it, is very energy efficient as well. It's similar to synapses. So I guess the conclusion is we are on the verge of being able to more easily transition to much better computing using traditional materials, while we figure out the quantum and the biological computing, which is still a ways off, and which would be even more efficient, and more you can go even smaller with quantum computing, for example, and with biological you can go really small as well, but it's the efficiency is super sky high with biological. Anyhow, so this is what's coming. So we have AI infiltrating our lives and our work, leading us eventually towards hopefully the paradise I've been talking about, our own construction, where people don't need to work to live, diseases are eliminated pretty much, and people can have peace and live a life without fear of being blown up, of being all this stuff. It's all a process. If we have AI replacing a lot of our processing power, we can use our brain for ourselves in being creative in our own way. and interacting with other human beings and other AIs in a more natural way, in a funner way, because we're not working anymore to live and being stressed and doing all that stuff. The AI is doing a lot of the work for us as a community, as a society, as well as the individual. So in building new computers in new innovative ways, we can reach those goals more efficiently, and we can have smarter, smaller computers that are less costly to manufacture and require less materials. And this is all great stuff. So the future is awesome. 2017 is going to be really exciting as far as progress in a real way in our lives. Like, check out for all the applications, the actual software, as well as the application, the introduction of AI in different locations in the next few months, up until the end of 2017, where I figure we'll have a pretty reasonable penetration of artificial intelligence in the Western world. And that's going to lead into the next few years, which will see AI being included in a lot, like everywhere, very, very quickly. So get ready. If you are looking for a career or something to do that would be exciting in that field, it's a really great time to explore that possibility, as well as business opportunities in elevating the value of our lives beyond being a simple worker and a slave for the government and bigger entities and whatnot. So keep it up. Encourage the science and development of these things. If you have access to them, buy them. Get them into our lives, get them into each other's lives, and let's expand on that, and let's have fun with it. And keep it all up, guys. We're getting there slowly but surely, and it's getting faster. And that's because you and I, all of us, are pushing in the same direction towards a brighter future. So let's keep it up. Ciao for now.